If we want to solve the following heat problem, derivative of u with respect to t equals to 3, second derivative of u with respect to x and x, when x is between 0 and pi and t bigger than 0, we have boundary condition that derivative of u with respect to x is 0 equals to 0 and derivative of u with respect to x at pi equals to 0. So we have endpoints of our wire insulated. I have initial condition when time equals to 0, u of x 0 equals to x. We know how a general form of that solution is going to look like. So u of xt is going to be equal to a0 over 2 plus sum n from 1 to infinity an e to a negative b pi n over l t pi n l squared cosine of pi n x over l. In our case, l is the length and the length is pi. B is a coefficient of second derivative of u, so it's 3. So we're going to get u of xt equals a0 over 2 plus n from 1 to infinity an e to a negative 3 n squared t cosine n x, where to find an, we're going to be doing 2 over l, integral from 0 to l, f of x cosine of nx dx. So we're going to get 2 over pi, integral 0 to pi. We have f of x equals to x cosine of nx dx. Firstly, we're going to calculate a0. a0 equals 2 over pi, integral 0 to pi x dx. So equals to 2 over pi x squared over 2 from 0 to pi. 2's will be cancelled out, so we're going to get pi squared over pi, so equals to 2 pi. So that is our a0. Now, to find an, when n is not equal to 0, we're going to write 2 over pi integral 0 to pi x cosine nx dx. So we're going to do integration by parts. And when we do integration by parts, we start with x, derivative of x is 1, and we have cosine of nx. Antiderivative of cosine of nx is sine of nx over n. So we're going to get 2 over pi u times v x sine nx over n minus integral sine of nx over n times 1 dx. So we're going to get, and everything is changing from 0 to pi. So we're going to get 2 over pi x sine nx over n. Antiderivative of sine is negative, cosine minus minus give us plus, plus cosine of nx over, we have n, we have to put an extra n, so we're going to get n squared. We're doing it from 0 to pi, so we're going to get 2 over pi cosine of pi n squared minus 1 over n squared, because sine of pi n equals 0, cosine of pi n over n squared, sine of 0 equals to 0, and we're going to get cosine of 0 is 1, so minus 1 over n squared. And that is our expression for n when n is not equal to 0. I'm going to write down one more time expression for n, and what we notice is that expression equals to 2 over pi. We can factor 1 over n squared out, cosine of pi, and we can write that as negative 1 to n minus 1. So what we notice is 1 to the even power, negative 1 to the even power is positive 1, and 1 minus 1 equals to 0. So when n is even, an is going to be equal to 0. And when n is odd, an is going to be equal to 2 over pi, 1 over n squared. Negative 1 to odd power is going to be negative 1, so negative 1 minus 1. So we're going to get minus 4 over pi n squared. So now we are ready to write down our answer. What will be expression for uxt? Uxt equals to a0 over 2. You recall that a0 equals to pi, so pi over 2 plus. Here I want to go by odd n only, so I will be saying that I will be going by a2k plus 1, and I want to start from k equals to 0 and go to infinity, and we're going to get e to the negative 3 times 2k plus 1 squared t cosine of 2k plus 1 x. So final expression for our function is going to be pi over 2 plus, and we're going to substitute negative 4 over pi n squared for a and 2k, so we're going to get k equals to 0 to infinity, negative 4 over pi 2k plus 1 squared times e to a negative 3 times 2k plus 1 squared t multiplied by cosine of 2k plus 1 x. And that is going to be our solution for this heat